Okay, today we'll be looking at the questions for the midterm for EBT 1100. The first question asks, compare and contrast the following items related to our recent efforts to apply statistics to engineering applications. Describe the uses of mean, median, standard deviation, and confidence intervals. Well, talking about mean first, mean is an average of all your data. So most common way and pretty much the only way to find a mean is add up all your data and divide it by the number of data values you have. It'll give you the average, and that's considered the mean. The median is considered the midpoint, the middle data value that lies directly in the center. If you do not have a data value that, like an even number of data values, and there isn't a dead center one, you just add the two inner ones together and divide by 2, and you'll find a number in between those two numbers, and that would be considered your median. Standard deviation is numbers away from the mean. So the standard deviation tells you is a number that will tell you how far away you are from the median, or not the median, the mean. So it's standard deviation is different for every data value, just like the median and mean will be, and it's just telling you how far away you are from the average, per se. And then confidence intervals is like a probability. So on a standard bell curve, confidence intervals is the breaking up of the data. So here's your average would be about in the middle, where most of your data falls, and then out here your outliers. Confidence intervals is a probability of any of this happening. So if your data is here, it's in this confidence interval, and then you find the probability of that data in the middle, more towards the middle here, is going to have a higher probability, and the data out on the outside will have a lower probability. And then the second part of question 1 asks, how can such statistical values be computed using a spreadsheet tool such as Microsoft Excel or Google Sheets? Both applications, both softwares, have a function tab where you can search. But if you know the names of each of these, all you have to do is go to a cell, type enter, so it knows it's equal, so it knows it's a function. And then I know on Google Sheets the function is average, if I can spell. And then you put in your cell number, so say cell 1A to cell D3 possibly. On Microsoft Excel, I believe the function is just called equals mean, and then the cells you want to find the average of. Median, pretty much the same case, equals median, and then the cells you want. Standard deviation is a little trickier. I believe it's STD, EV, and then it's dot, and then it's either S for sample, or it could be P for population, whichever one. If you want standard deviation for the sample, it's dot S. If you want standard deviation for the population, it's dot P. And then confidence intervals, I do not believe that there is a function to find confidence intervals. So we'll move on. Question number 2 asks, compare and contrast the approach you can take when creating the following types of technical documents. Describe the software you recommend for SOP creation. So SOP. List the benefits and shortcomings of your choice of software. Well, SOP stands for Standard Operating Procedure. I just realized I spelled procedure wrong. Procedure. Anyway, now I'm horny. The software I would choose to use for this would be, I would choose Word slash Google Docs, kind of Google's equivalent. The reason being is standard operating procedure is usually instructions, and you want to be able to write out words, detailed words, lists, stuff of that nature. Word does offer the ability to Word does offer the ability to put in tables, graphs, anything of that sort, which is not usually necessary for a standard operating procedure document, but if the case may be you might need them, then they do offer that ability. I believe the shortcomings of Word would possibly be, depending on what software you're using. Docs does have a lot of shortcomings when it comes to the technical, where you want to put lines at to like break up your document, headings. You can't copy such documents as exact in Google Docs. Word does a pretty good job of being able to copy documents if you want like the exact same document you've had before. Does a pretty good job. But of course there are shortcomings in every software you use, but the biggest shortcoming in using any document or any software program would be your ability to use it. So as long as you know your way around Word pretty simply and pretty well, you should be able to be just fine. Second part of question 2, describe the software you would recommend for forms creation and list the benefits and shortcomings of that software. So forms, again, I would say Word or Docs. Reason being is all the reasons I just listed. You're able to put in tables, you're able to put in graphs, paragraphs, words, any other kind of details. Yes, so I would believe that forms would be the best well done on Word or Docs. It's just Word, isn't it? Docs is the one with the S. Again, the same shortcomings, but the biggest shortcomings when using Word or Docs is just your ability to use it. So as long as you've been using it for a while or know what you're doing in the slightest, you'll be able to figure out find the solution to most of the problems you may occur when trying to copy a form. I would not recommend, for either of these, I would not recommend a spreadsheet software like Excel, just because on most of these you're usually working with words and places where people are going to sign their name, write down stuff of that nature. So Excel wouldn't be the best choice. And going into the part 3 of question 2, when is it better to use spreadsheet software like Excel rather than word processing software? So Excel versus Word is what it's asking. So the biggest difference between the two is I believe Word is more for writing out, using words, making paragraphs, lists, data, anything like that. Rather, Excel is more for putting listing data. They give you the cell spreadsheet. You can define, you don't need to use much words other than to define what the data you're putting in means. As long as you're working with numbers and graphs and tables of that sort, Excel would be your go-to, but anytime you want to explain something, write details about anything, Word would be your better option. So for things like this up here, Word is your go-to. For things like data values, data tables I should say, graphs, and anything data organizing, Excel would be your go-to. Alright, going on to the final question. Compare and contrast the approach you take when using spreadsheet capabilities for the following situations. So the first situation, describe 3 advanced functions available in Microsoft Excel and their use in performing calculations in environmental engineering. Recall functions from assignment number 6. The word advanced is, I would say, an opinion word. Some may consider simple functions like the mean and average to be advanced, but not too advanced for myself since I've been using this and for the last couple months. But we'll start with one of my favorites. Is the count F function, and then it's got its parameters you got to go through. Pretty much what this does is that it'll put out a data piece. It'll put out 1 or 0 or possibly anything else depending on how you have it set up, and it just checks. So if you it checks the data, the cell you put it in. So if you say greater than 15 in cell C18, that's not the exact order of the parameters, but you get the idea. It'll go to cell C18, and if the number in the cell C18 is less than 15, it'll put a 1. If it's greater than 15 or equal to 15, it'll put a 0. So it's a good way to find out if find out how many data pieces you have that are within a certain range. The next function we can talk about going off of this is COUNTIF-S, which is a bigger version of COUNTIF. So now, instead of checking for just less than 15, it could check for less than 15, or it is greater than 34 in a certain cell. So we'll go cell 8 or C18 for the cell, just like we did on this one. So now it'll check if the number is either less than 15 or greater than 34, and if it meets any one of those requirements, and it'll put out a 1. If it meets none of these requirements, it'll put out a 0, or depending on how you have it set up, if it meets one or the other, it'll put out a 1 as well. Again, a good tool for to use if you're trying to find, data pieces, how many data pieces that fall in a certain range. Also good, and you just want to know how many and the third function we'll go into is an if function. An if function is considered a logic test. So what pretty much all you do is kind of like a COUNTIF function, except you'll give it the parameter. So we'll say is equal to or less than 13. We'll go to 13, and then you say, and then it asks if it's true, what do you want, and if it's false, what do you want. So if I want to check to see if a certain range of cells is less than or equal to 13, and if it is less than or equal to 13, I want it to put out maybe a T for true or an F for false. So now what it'll do is in the certain cell you have set up for it, when it checks the cell you're asking about, if it's less than or equal to whatever value, in this case 13, if it is, it'll put true. If it isn't, it'll put false. You can't actually put true or false. You usually put a data value, but just for the sakes of teaching TNF. And now that I've realized when you're doing the count if functions, these are actually backwards. In the count if functions, it asks for the range and then the criteria. Rather than the criteria, than the range. So the range is the cell you're looking for. Criteria is the greater than, equal to, less than kind of deal you got going on. So that will be it. Those are three more advanced, considering on how you look at it, functions you can use in Excel. And the last part of question 3 says describe the use of X and Y scatter plots and include an example of data that would fit such a visual or graphical output. Mention the benefits of axis labels, multiple axis for the units of measure, and other interests. So what it's asking is, in Microsoft Excel, you can have a graph, normal graph. You have Y over here, X over here, but also you can put in a second Y-axis. So why would this be beneficial? Well, in the case of talking about maybe temperature, degrees Fahrenheit or degrees Celsius, in this case you could have Fahrenheit over here, Celsius over here, vice versa, and down here maybe time, a time measurement, so either like a date, date, time of day, or any other kind of time value. And then over here you can have degrees Fahrenheit that match up with degrees Celsius. So quite simply, 212 degrees Fahrenheit is equal to 100 degrees Celsius, and then 32 degrees Fahrenheit is equal to 0 degrees Celsius. So now they'll all add up to each other. So when you have two pieces of data, so whatever this may be, taken at a certain time, now you can put them, all three of these, on the same graph, and they'll all line up together. It's beneficial when working with two different types of dependent values. So, of course, X is the independent value, Y is the dependent value. So when you're working with two different types of dependent variables. And as far as that goes, I believe that might be it. Thank you for watching. Have a good day.